Hello to my all friends. Welcome back to the new video where I'm going to discuss a NoSQL research paper where we're going to see the SQL versus NoSQL for the Internet of Things databases. So Internet of Things is provides an environment where many devices come together and interact with each other where they share and gather information and but to manage those vast informations we definitely need a database to store where a traditional SQL database which is reliable but faces limitations in handling the complexity and the scale of internet of things data. So this presentation explores the advantages and disadvantages of the SQL and NoSQL databases for the Internet of Things applications, providing the insights on their suitability for different scenarios. Let's begin. Seeing the comparative analysis of the SQL versus NoSQL for Internet of Things. First thing we encounter is the CAP theorem. CAP theorem, this states that the distributed database system can only satisfy two out of three properties, that is consistency, availability, and partition tolerance. The SQL databases prioritize consistency, ensuring the integrity even when the network fails. The NoSQL database prioritizes availability, allowing access to data even if some nodes are unavailable. Coming on to the acid property, which is elaborated as atomicity, consistency, and the durability. The SQL databases adhere to the acid property, and these properties ensure that transactions are executed reliably and data remains consistent. NoSQL databases, on the other hand, often relax these properties to achieve higher availability and scalability. The base properties, which are followed by NoSQL, that is basic availability, soft state, and eventual consistency. These properties prioritize availability and allow for temporary inconsistencies, which are eventually resolved. This approach is suitable for applications where data consistency is not critical. The characteristics for IoT applications that are mainly as scalability, data retrieval speed, system maturity, and security. The scalability is very crucial for IoT applications as the volume of the data generated by connecting many devices, as I discussed, can grow exponentially, which is hard to maintain. So the SQL databases typically scale vertically, adding more resources to a single server. No SQL databases, on the other hand, often scale horizontally, distributing data across multiple servers. The data retrieval speed, which is very important factor, where the efficient data retrieval is essential for real-time analysis to make decision in IoT applications. The SQL databases excel in complex queries using join statements but can be slower for large data sets. NoSQL databases with their object-oriented data models often offer faster retrieval for specific data points. The system maturity and security. SQL databases have a long history and established security features, making them a reliable choice for critical applications. NoSQL databases are relatively newer and their security features are still evolving. However, they offer flexibility and scalability that can be advantages for rapidly growing IoT deployments. Now we see the case study of a water sprinkler system, which is mainly divided into four stages. The first one is sensor data collection, where the temperature, humidity, and soil moisture sensors gather real time data from the environment. In the data transmission stage, sensors transmit collected data to a central database server for analysis and processing. The third stage of it is database storage and analysis, where the database server stores and analyzes the collected data to determine the optimal watering schedules and trigger sprinkler activation, which will in fact save the water and can be used as the resources efficiently. The sprinkler activation is done based on the analysis where the sprinklers are activated to provide appropriate watering on the environmental conditions. The experimental setup and tools are Arduino UNO board that is used for collecting sensor data from environment, MySQL database that was used for storing and analyzing sensor data, MongoDB database used for storing and analyzing sensor data, providing a NoSQL alternative to MySQL. Then the Apache, which is used for performance testing and analyzing the response times of both data sets databases. The results gathered from the experiment are in the select queries where the response time versus number of threads. The experiment measured response time of select queries for both MySQL and MongoDB databases, varying the number of threads concurrently accessing the database. The results showed the MongoDB consistently outperformed MySQL in terms of response time, especially as the number of threads increased. Response time versus number of records. The experiment also analyzed the response time of the select queries as the number of records in the database increased. MongoDB demonstrated better scalability, maintaining faster response times even with a larger dataset. This highlights the efficiency of MongoDB's data retrieval mechanism for handling large volumes of Internet of Things data. The experimental results on insert queries. The experiment measured response time of insert queries for both the MySQL and MongoDB databases, varying the number of threads concurrently accessing the database. MongoDB consistently outperformed MySQL in terms of response time, especially as the number of threads increased. Response time versus number of records. The experiment also analyzed the response time of insert queries as the number of records in database increased. MongoDB demonstrated better scalability, maintaining faster response times even with a larger dataset. That highlights the efficiency of MongoDB's data retrieval mechanism for handling large volume of IoT data. The conclusion and the future developments. The comparative results are the experiment demonstrated NoSQL databases like MongoDB offer significant performance advantages over SQL databases like MySQL in handling large volumes of data and high concurrency in IoT applications. The database selection recommendation for IoT applications requiring high scalability, availability, and fast data retrieval, NoSQL databases are a suitable choice. However, for applications demanding strict data consistency and complex queries, SQL databases remain a reliable option. Future research directions are further the research can explore the hybrid database approaches that combine the strengths of both SQL and NoSQL databases, leveraging the best of both worlds for optimal performance and data management in IoT environments. By this, we come to the end of the video. Thank you for being with me till the end. Hope you have a good day.